the first part of the video, about electrical machines, we know the basic relationship between torque and rotational speed. The motor shaft can rotate clockwise, or counterclockwise, and the torque takes either positive or negative values. Therefore, for operating quadrants of electrical machines, are defined. In the first quadrant, speed and torque take positive values. Therefore, the machine operates as a motor, with a clockwise direction of rotation, and the power is positive. The equivalent circuit refers, for simplicity, to a DC machine. In the second quadrant, the torque becomes negative, while the velocity is positive. The machine is in braking mode, operating as a generator, and the power is negative. Depending on power converter operation, the electricity generated by the machine. A. Directed to source, V1. B. It is consumed in the braking resistor. C. It is consumed in the internal resistance, Ra, of the machine, together with the power supplied by source, V2. In the third quadrant, speed and torque take negative values. Therefore, the machine is again operating as a motor, but with counterclockwise rotation. In the fourth quadrant, the machine is in braking mode, as in the second quadrant, while rotating counterclockwise. Note that the torque on the passive loads is opposite to the direction of rotation. The active loads, on the other hand, are the ones that cause the machine to rotate. Furthermore, the load torques that carry a continuous line cause the machine to run in a steady state. In contrast, the machine only operates for a transient period, with the load torques denoted by a dashed line. The operating quadrants of the electric machines acquire physical significance, in the crane shown. To lift the load, the crane machine rotates clockwise, developing a positive torque, opposite to the torque of the passive load. Therefore, the machine operates as a motor, in the first quadrant. In order for the crane to lower the same load, its machine must rotate counterclockwise. Now, the load is active, as it causes the machine to rotate. In order for the load to descend, at a constant speed, the machine must develop a positive torque, equal to that of the load. Therefore, the machine is operating as a generator, in the fourth quadrant. The power converter determines how the generated electricity is managed. To move the electric vehicle uphill, its machine works as a motor, in the first quadrant. To accelerate the vehicle, the motor must produce a positive torque, greater than the load torque. To move the vehicle at a constant speed, the torque produced by the machine is equal to the load torque. When the machine torque is less than the load torque, the vehicle decelerates slowly. For rapid deceleration of the vehicle, the torque must become negative. The machine operates as a generator, in the second quadrant, producing electricity, which charges the battery. To move the electric vehicle downhill, the machine operates as a motor, in the first quadrant, continuously accelerating the vehicle, in combination with the load torque. To move the vehicle at a constant speed, the machine must produce negative torque, so it operates as a generator, by charging the battery.